Welcome to the All Things DER podcast, brought to you by AEIC. In this podcast, we dig in, define, and discuss where the new energy economy is heading with electric industry leaders and explore all the ways that distributed energy resources can modernize and improve our ever-evolving power grid. Thank you for joining us.
Hello. Welcome to the All Things DER podcast. I am happy and ready to have a great conversation with Gregg Kresge, who is the Senior Manager of Utility Engagement and Transportation Electrification at WRI. And so with that, I wanted to give Gregg an opportunity to introduce himself and kind of what are we going to get into today? What's your day-to-day all about?
Well, we'll be talking about DERs, of course, distributed energy resources. So I will start by giving a little brief history of me and kind of my background. I've worked 16 years in utilities. 12 of those have been in electric utilities. The other ones have been actually in wastewater and solid waste. I have actually an environmental background to begin with, and then later went on and went back to school and got an additional master's and PhD in sustainability and green building, and I'm also lead AP building design and construction, as well as a couple other, energy efficiency sort of certifications. The other thing is that when I was working for the utilities, I started out as an environmental, and this is in the electric utilities. I actually started out about 5,000 miles away from the California West Coast on a small island called Saipan, which is in the Commonwealth of the Northern Mariana Islands, and they run diesel gensets to generate power on 3 islands. So that's where I got most of my major start, and actually that was for power generation, wastewater, and water utility. And then when I moved to Maui, so now I've lived on Maui for about 20 years, and when I moved to Maui, I got the opportunity also to work about 11 years ago for the Hawaiian Electric company, Maui Electric at that time. Started out as environmental, and then I was given the opportunity to temporarily manage the power generation for 3 islands. Again, it's 3 islands, Maui, Molokai, and Lanai, that all make up Maui Electric, or that electric county system. Those are all separated grids. So what a lot of people don't realize in Hawaii is we have no underground cable connecting us to each other. Every island is on its own. So you generate electricity from renewable resources. That's great, and especially when you have a lot of them, but you also have to consume everything that you generate, or you have to curtail. So right. There's been a lot of changes to the electrical system. And then after doing that, I was given the opportunity to be the manager for all renewable energy projects, and that's interconnections, that's utility scale, that is, and we had energy contract managers, we had interconnection specialists and DER specialists. We handled everything from small rooftop PV all the way to, like I said, utility scale, 3.8 megawatt wind turbines, and 72 megawatts total in wind, and over 105 megawatts of installed PV. At that time, most of it is uncontrolled rooftop PV. When NEM hit here, when you have 30 cents a kilowatt hour, it makes sense.
It was an easy sale.
Yeah. So now, and then I was given an opportunity to do something on a little bit more of a national and global scale by going to work for WRI, which is really great. It's given me the opportunity to speak to utilities and engage with people all across the nation.
Well, I just have to say, being a fangirl of DER in general, getting to speak to someone from Hawaii is like the mecca, because ultimately you're a microcosm of the much larger grid, and you've been dealing with all of these phenomena that we've been talking about here on this podcast for probably 20 years at this point. So it's really great to have an opportunity to kind of pick your brain and share your experience, because I think one thing, a lot of us who have very intertied grids and interconnected and interwebbed, it's not going to happen. However, what you've probably learned, and we're going to hear, is it's not about the large grid. It's down at the microcosms of like what you have to worry about, and the small changes that become very big changes on how you plan, how you interconnect, how you manage, how you operate, and really that technical acumen that has to be within. So I'm very excited to talk to you. So thank you for taking the time today.
Yeah.
And so we did talk, distributed energy resources, and one thing that's happening, especially in season 2, is, this word electrification. It is kind of playing one for one with DER. So what's your perspective? What does electrification mean to you and relate to this topic?
It's interesting because when I was working for the utility and in Hawaii, starting out in environmental, and I was responsible for air compliance. So we have fossil fuel gen sets, many of them. So across the 3 islands, there were 44 generators in our fleet, and each of those has major air compliance issues. So the interesting thing is when I started talking to others in other groups and other organizations, and there was this term electrification. For me, it was a little bit confusing at first because in Hawaii we are electrified. We don't have piped natural gas ever here, very rarely, unless you ship in your own or unless you live in a special area where those outlets have been put in to be able to pipe in natural gas. You don't have natural gas. Everything is from the electrical grid or generated on site by say solar panels. So. Yeah. So then I was like, okay, well, if the thing that is a concern for me in DERs when we're talking about the big scope and the big picture is that when you're looking at electrifying and you're actually looking to remove large loads, especially the largest loads in your house, from gas and you're going to electricity, there's going to be a tremendous amount of demand placed on that system. And the reason is because those are the big 240 volt 240 208. They're going to be hot water heaters, ovens, dryers, those sorts of things which people just kind of take for granted right now that aren't part of their electric bill. And so they're going to see a huge increase, and this is what we see also on the EV side. People don't realize that electricity isn't free when it goes into your car, and when you're electrifying other devices. You're now displacing your gas bill with an electric bill. So while it's a different type of fuel, the beauty of that, and part of the great thing about electrifying, is that unlike fossil fuel industry where there's a lot of volatility across the board in fossil fuel prices, and this is especially in transportation, but the electric rates are typically set for a pretty long period of time, and they only allow for a certain amount of recovery, so that really evens out a lot of those spikes. So if you're looking at electrifying, one of the great benefits is that you're going to be able to budget more accurately because you're not going to see these huge swings in prices or shortages. You're not going to be waiting. If you change to an electric vehicle, you're not going to be waiting at the gas pump to fill up your car. You'll be able to do that hopefully from your home if you live in a place that you can install a charger. So I don't know if that answers your question.
Like when we think about it, so you're electrifying a significant amount of loads that we're not really considering. But what I think, when you said an increased demand, one thing that we have to do in parallel is, or complementary, and take action is using our energy smarter. So having these devices are now manageable from like a technology perspective, right? So now you have this, now electrification is all about DER because now you have an active management of the edge, which is kind of what we've all been concerned of with solar, and why we talked about it for so many years is because it wasn't dispatchable and it would just happen, therefore the grid had to respond. So now we're kind of coming full circle. If we can be smarter with the technology to really what's a better word than manipulate, but like incentivize humans, us beings, to use less energy. And you really can't do that with gas or fossil fuel connected, right? But you can with this newer way of managing the grid at the edge. So,
and I have one thing to say about that, which is just that is the opportunity that is available, and across the nation, it's time of use pricing does work. Cost is a motivator, If you make it more expensive at more expensive times of the day when less renewable energy is coming in or your cost of energy is higher, and you reflect that in the rate, people will, start participating and realizing if they can save a lot of money by changing their habits. If they can, then they will.
Right, and that was going to be my flip question to you, was have you seen, by creating this time of use or, incentivizing, however we want to say it, work. Mm-hmm. So it's definitely something at our fingertips, which again, if you think about where we've been on this journey, especially you, like these are things that you had to learn by doing, and you can't learn unless you do and imply, and Hawaii's been doing it for a while. So another thing I heard you say was, this increased demand. So when we flip it to DER in general, like, mm-hmm. do you think our existing grid, Hawaii or the larger, is capable of meeting, and what are your parallel thoughts? Because we just shared a few, but of what needs to come together.
So I'm going to go back to kind of what you mentioned at the very, very beginning of this podcast, where you brought up the M word, which is microgrid. So for us, a lot of, we have an island whose total load, it would be considered a nanogrid, not even a microgrid, because the energy consumption is so small, and this might not mean anything to anybody out there, but there were times when we got to about 1.5 megawatts for an entire island feeding 8,000 people electricity. That is less than that. That's one generator.
Right. That's
yeah.
amazing.
I mean, so when you're talking about this, one of the things that we're going to see that is already happening, and you're going to see this especially in the transportation sector, where people are going to be looking at using residential battery storage through their vehicle, being able to backfeed to their house. That's going to create this microgrid environment. So if there's grid disturbances and there's, opportunities where you can generate on-site solar and then you can actually fuel your vehicle from that and then later backfeed. This used to be a thing that I tell people, this used to be a $80,000 to $100,000 proposition. If you wanted to go off-grid and you wanted to do this for yourself, and it wasn't funded, meaning like you had to come to the table, it wasn't wrapped into your mortgage, that sort of thing. We're seeing a complete change in that area now. Now DERs are becoming available to people. There are community solar programs as well. There's a lot of potential avenues coming down the line for people to be able to get involved, even those people who don't have their own rooftop, to be able to participate in renewable energy, in addition to these sited storage devices that are also taking this energy and storing it for later. And maybe it's off, and I always recommend, if you're going to do that, offset your own load first. Don't send energy back to the grid unless you need to, because that requires a whole bunch of other parts to it, vehicle to grid or grid integration, that would require electrons to flow back beyond the meter. There's a whole bunch of safety requirements. But we're seeing now that people are being able to generate, use their site, use their electricity. And part of the way that I know about doing this is because I do it. I have a Tesla Powerwall on my house. I have 30 panels on my roof, and I have 2 electric vehicles. I'm fortunate enough to be able to do that. But part of participating in this realm and keeping up to date with what's going on is actually participating as a person, as opposed to, in theory. How is it really working? And how is it able to be done? So I think we're going to see a lot of that in the future, is more and more microgridded environments where there's going to be some, residential or commercial sided storage and generation that's going to become more prevalent.
And ultimately it's becoming more prevalent because increase of adoption, it's becoming mm-hmm. available to others from an economics perspective, kind of like all things, we once had horse and buggy, and then we had a car that made it all happen for us, and 10 years later there was no more horse and buggy. So you're if we think about the journey that we're on, we're kind of we're at a tipping point, right? So you're going from a place where it used to be not really affordable, but those green tech savvy that really wants to be a part of that solution, bid in. But now we're kind of on the other side of the needle, where it can become affordable and also become a way to stabilize and help the overall future grid. Is that an experience you're seeing?
Yeah. So when we go out and we're, advocating for electric school buses, for example, I'm going to bring that into the discussion, but when we're advocating for electric school buses, which are medium and heavy duty fleets with large battery capacities, they could potentially have a large load associated with them if you drive back and you plug in, and especially if that's high speed charging or fast charging, that's a jolt to the system all at one time. What we advocate for is never advocating for, we always advocate for managed charging. And that's because we want everybody to participate. If there's a chance to plan now and be part of the grid solution because it affects all of us, then that's what we want. We want these to be grid assets. We don't want them to be detrimental to the grid and charge at inopportune times or result in starting up a peaker plant, which is a small generating device that tends to be less efficient, but it's there to meet that immediate load that can't be met through other generating sources or started up in time for the more efficient units. And those tend to be in the evening or daytime peaks, depending on where you live, based on your temperature and climate and that sort of thing. But I think that with this, there's going to be this continued interaction with these DERs, and if they can be done smartly, and people can start out thinking that they're going to be able to operate it from an app, get text messages, know when it's like, if you have a Nest device or a thermostat device, knowing, not heating your house for, my dad used to have to get up at 6 o'clock in the morning, 5 o'clock in the morning, and he would start up the heater so that everybody in the house would be warm by the time, we had to get up and go to school. Yeah. Now at this point, if you wanted to set that thermostat for 10 minutes before you got home and walk into a warm house, you could do that. You're wasting a lot less heat. It's not as much of a demand. And then if there's a grid disturbance, you can reduce your consumption just by a couple degrees. And everybody doing that in aggregate would make a huge difference. Those are the participatory.
And just, I don't know why I thought of this, but when you go to restaurants now and they have the QR code where you're going to eat, which assumes that everyone that comes now has a smartphone. Would we have ever done that 5 years ago? Maybe even 3 years ago? To make the assumption that every customer that walks through the door of your business is going to be able to talk to the QR code. So I think we lose sight of how quickly we can embrace change that actually helps us. But while we're all talking about change, everyone wants to just revolt against it. So
yeah,
I guess
there's a lot of so this is an interesting paradigm, because what people don't realize is they're willing to accept certain devices that have communications. So you're carrying around your cell phone all the time, right? And this is nothing new to anybody else, but in a lot of cases, your cell phone listens to you. Why do those ads pop up at the time when you're like talking to somebody about it, and then all of a sudden, boom, you have an ad on your phone? The other thing too is your location services. Where's the closest ATM? That's a back and forth communication with your phone. What people don't realize is like, oh, I don't want to give you visibility into my refrigerator or to my hot water heater or into any part of my house. But in reality, like if you have a PV system, that PV system is talking to the grid all the time and updating firmware and having this communication go on as part of its function. In Hawaii, we don't allow dumb inverters anymore. I mean, they're all smart inverters. They have to have some communication with the grid, recognize grid disturbances, and then curtail on their own if it gets to that.
And if you think about it, that fundamentally was the only reason is it's a safety and aka reliability reason, right? Not from I want to control. It's like I want to keep you safe and I want to keep the grid reliable. Therefore, we will need to make these inverters manage to the bulk grid that it's connected to. And I guess I just want to say with those algorithms that we are all eager to like allow into our lives that really end up sending money away from us, we could start using that intelligence to save us money. Maybe that's like our new thing. We should really communicate that, like we can get more intelligent with our energy use devices, and it's happening. It's just that adoption rate needs to increase, right? If we want to embrace this. And it will save us money in the end if we're using our energy differently. So that's very exciting.
Yeah. Well, I have a great example, just real quickly. So I have 30 panels on my roof. And so one of my panels, I have an app that shows me the output. One of my panels was producing half the amount of all the other panels, and showed up black, instead of green on my device. I called the installer. They're all under warranty. I called the installer. I said, "Hey, I'm only getting half the output on this panel. What's the deal?" Well, it turned out that it was a inverter issue and a communication issue, and it came out. They found out what it was, and then they ordered the part, replaced the part, and now my panel is producing full output. Saved me money.
Yeah.
That's an extra,
Yeah.
Yeah.
So I guess from pulling up a little bit, like, you've experienced really the realm from an interconnection to an operation perspective in your experience, based on what I hear. What are some lessons learned from those leaders of utilities that are starting to embrace this idea of grid modernization, right? Which grid modernization ultimately means full situational awareness at the edge so that we can manage all of this new technology from the bulk generation that's changing rapidly, aka, your intermittent renewable resources, all the way down to all of the gadgets and gizmos we just talked about. Just from your perspective, like, what would be, some lessons learned or advice that you would want to give those leaders of what to embrace and really when?
If I could sum it up in one word, I would say proactive. Well, 2 words: proactive planning. And the reason is because it would be different if you didn't know that this was coming. But come on, we know this is coming, and you can anticipate, and you can actually model and forecast. The big difference, and I've been listening to a lot of, people talk about this, and it's been vocalized pretty often. Actually, I think I just heard something yesterday in another, avenue I was listening to, that was around, utilities are not used to putting money up front that they can't recover for right away. Right, so you go, especially if it's an investor-owned utility and it's regulated by a public utilities commission or a public service commission, you have to go and get approval. Especially if it amounts to something over a certain threshold, you have to go and do a tremendous amount of work to get that capital budget funded, and then you're allowed a rate of return. Now, that's different from munis and co-ops that are smaller. They're run by boards and commission, or boards and smaller commissions, or they're localized, and what they invest comes from the ratepayers directly. There isn't a profit margin in there for them. They're taking that profit and putting it back to the customers who own the system. With that being said, the thing is that we have to get over this mindset, and this has been forever and ever and ever, which is you're the one who's causing this disturbance on the grid. You're going to have to pay, and we're not going to do anything until you pay for it. So then we get into this situation of like, okay, well, finally there's this amount of infrastructure improvement that needs to be done. Okay, we're going to build a substation for the tune of $100 million. I don't know what but yeah, so or higher. It's very expensive to build substation. But the thing is that so instead of building a substation for future consumption and future use and future distribution, you're building the substation only when you have enough, and you have these customers who come to you and say, okay, we want to interconnect, and then when you have the right amount of customers that can pay for that substation, then you build the substation. Okay, wrong. We are in a period of time
that's planning.
Yeah. But the thing is that so this is also
more.
Within the regulatory environment, right? We need to also educate regulators and say we are going to have to take some risk here.
Right.
I know that's utilities especially are very risk adverse. And that's around shareholders and return on investment and allowable return. So so what we have to do is we have to say, we are planning for this. We are modeling for this. I think we're at the point where you said it's a tipping point. We now see that this is going to be happening with a very high level of certainty, but there is still risk, right?
Right.
So there needs to be some of that.
But there's always risk.
There's always risk. There's always risk.
It's just a different flavor of risk.
It's a different flavor of risk. Yeah.
I'll just share a secret of some of my intention behind this podcast is to educate all those regulators. So, hey,
Right.
if you're listening.
Yes.
But,
All right.
but really, because I think you become comfortable knowing what to do. And
Yeah.
so we're at a point where we need to pivot. And so I guess from like a lessons learned perspective, like that flipping the switch, no pun intended, or a mindset shift around the perspective that one must take. Like I think there's this overwhelming unknown for like the journey or the vision of a grid mod or like how to modernize said grid assets that you almost are paralyzed. So
Yes.
I truly believe, and maybe let me know if you agree, that if you're able to flip the switch and really get behind where we're headed with how energy is used differently, and that we will, as a society, embrace those small changes, that it's just a 1 + 1, right? You kind of just put one foot in front of the other, and you don't have to overhaul your whole organization. You just have to really have that shift.
Yeah, and I think, and this is where I feel like utilities have a really big role to play in this, but it's across the board, which is really involving and educating the public in general around, what is renewable energy? What are the potential, generating sources? What is feasible in my area? What can I do now? Where would we be going in the future? Can I have a say in what that is? What does it mean to have a solar farm near your house? Are you going to get any of that energy? Are you going to be able to add on to your own? I think the other thing too is we went from a time when flipping the light switch was all anybody really knew, or replacing the glass fuses, or not that I would remember that, but even a panel box, right, in your house with circuit breakers. It's really still the unknown, and it's really scary to a lot of people. I think there should be some basic education that happens early on with kids. It starts with kids. What is electricity? What does it look like? How is it used? And and you get some of this basic stuff, but very little of that education that happens in the classroom is actually housed in reality, which is, okay, so here's not just the paperclip to the battery to light a little LED. Okay, yes, I understand that may show how the flow of electricity works. But what does it mean in your house? What does it mean for you? How does electricity get to your house? What is the grid? How is the electricity generated? What is a reciprocating engine, that generates AC? What is the difference between AC and DC, and what does that look like? Those terms are not until you, or if ever, really talked about in a common curriculum. And
that was another secret is, right, education, and how do we start education. So Greg, I just have to say, this is such a great conversation. I hate to cut us off, but one, I think we're kindred spirits, that you hit on all of the planning, active planning, educating the regulatory environment, and let's start young and start educating our youth is my biggest takeaways. Especially you've experienced it, you understand it, in your firsthand. So thank you for your time and your education. I look forward to further discussion as we travel this journey together.
Yeah, Elizabeth, thank you too. It's been very enjoyable.
That's a wrap for this week's episode of All Things DER. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.